Good afternoon. My name is Domenico Rotondi from Fincons SPA. I will present the eCAR encryption for confidential IR solution. The presentation is organized in this way. I will just spend a couple of slides about Fincons Group. Then we will go to describe what kind of issue we address in eCAR, and then to present the eCAR approach, architecture, the components that we have developed within the XR for All project, and just provide some quick demo and some more specific information about some of the components. The Fincons Group is a large enterprise with its group headquarters located in Switzerland and branches in Italy, UK, US, France, and Germany. Fincons Group is a system integrator and solution provider and acts on many market segments with usually our customers are big private companies. We are more than 600 people worldwide with an annual turnover that is above 150 million euros. These are the offices locations. Most of the Fincons employees are located in Italy, and all the development and technical support for our customers is done in Italy, and most of the people is located in the Bari in southern Italy office. Let's come to the eCAR project. So what is the issue that we try to address in eCAR? The augmented reality frameworks basically are based on having visual cues that are called markers that are recognized by an augmented reality application, and the recognition of a marker triggers the retrieval and the display of the information that has been associated to the marker using an augmented reality mode. The information that is associated to the marker can be static, for example, the title of a painting, or can be dynamic, for example, measures coming from a sensor. But the information is statically tied to the marker and is independent from the user. So all users get the same information. How we could differentiate the information content when the context is the same and the visual cues are the same? The traditional approach is to duplicate the information as is depicted here. So in eCAR, we are exploring a new area in which we combine the augmented reality technologies with new encryption techniques. And this combination is to enable the development of augmented reality applications that are able to customize the provided information, not only according to the marker that is recognized by the app, but also taking into account the characteristic of the user. So we are able to provide the customized information, taking into account the user characteristics, and so we avoid having to duplicate the app. The customization is based on a new cryptographic approach that is called CPABE, Ciphertext Policy Attribute Based Encryption. What is this new encryption technique? CPAB is an asymmetric cryptographic scheme, so each user has its own key, and by the way, the decryption could be performed using many different keys. The encryption process is based on an access policy that combines a set of attributes that specify what kind of characteristic a decryption key has to satisfy in order for the decryption process to succeed. So when you encrypt an information, you use an access policy, you use the public key of the key generation service, and the policy is used to encrypt the information. So the same information encrypted with two different policies generates two different encrypted data. The decryption process can be performed using different decryption keys. So each user has its own key, and the key is generated based on attributes associated to the user. For example, taking into account the attributes in the user profile. So if these attributes satisfy the conditions that are stated in the encryption policy, then the decryption process will succeed, otherwise it will fail. So in eCAR, we use these encryption techniques to protect the information, differentiate the information according to the user profile. What we provide and we have developed in the eCAR for All project is components that can be used on the mobile phone to support this kind of information customization, and a set of tools that can be used both for creating and managing the encryption policies, as well as for encrypting static data like PDF files or other kind of documents using the created policies, or for encrypting the dynamic data, for example, coming from sensors using one of the policies that you have created. Additionally, in eCAR, the data owner can create the metadata information to be associated to a visual marker. This metadata information can combine one or more data sources that can be encrypted or unclear. And so when on an eCAR augmented reality application, a visual marker is recognized, the metadata information associated to the marker is downloaded, and then the data sources that are referenced within the meta information are accessed, decrypted, and if the decryption succeeds, presented to the user using an augmented reality approach. The components that have been developed within the eCAR for All project are the JSON schema that must be used to structure the meta information to be associated to the augmented reality marker. Then we have a set of software libraries that must be used in combination with the Android AR core framework to manage the encrypted information that has been associated to markers. Then we have a WYSIWYG web application through which you can manage the access policies, you can create instances of the meta information to be associated to the markers, and encrypt the static data sources. And finally, the web application is also able to manage the markers associated to the that can be recognized by the eCAR enabled application. Finally, we have software modules for encrypting dynamic data. So you must use this kind of libraries for encrypting the data that, for example, that are acquired, for example, from sensors. All the components are provided as open source, and the code is available on the eCAR for All development portal, and specifically using this URL. In this slide, I will show a mock-up of the eCAR enhanced augmented reality application. What we will see is we have a virtual scene with a marker on the table. Then in the simulation, we will see a mechanic worker reading the marker and getting some information about engine. Afterwards, there will be a supervisor guy using the same application, reading the same marker, but having a different decryption key that will get additional information as compared to the initial worker. As you can see here, the worker is reading the marker. He gets some information regarding engine A. Now there is the supervisor. He reads the same marker but gets additional information, for example, regarding engine B. This is a quick overview of the web application through which you can manage the access policies. This application provides a drag and drop UI that is based on Google Blockly framework. On the left pane, you have a set of logical operators and a set of attributes that you can select and drag on the central pane. On the central pane, combining the operators and the attributes on the left side, you can create even complex access policies. On the right pane, we provide a file system like pane through which you can save, manage policies. Of course, you can edit existing policy and modify them to address new issues or have different policies defined. The web application, as stated before, can also be used for creating the instances of the meta information to be associated to a specific augmented reality marker. As stated, an instance can reference one or more data sources. A data source can be a static one or a dynamic one, can be in clear or encrypted, can be embedded or referred. An embedded data source means that the actual content is included in the meta information instance, while a referred one means that there is a URL in the meta information instance, and this URL is the endpoint through which you can get the specific data source. Of course, you can also select an access policy through which you can protect the information. This is the short presentation. Thank you for your attention. This is my email. If you have any question, please just send me an email. Thank you.